Hey guys, we are now going to start with section 6.1, angles and their measure. So the first thing we're going to do is we're going to define some vocabulary and some common Greek used letters, okay? Vocab and theorems, here we go. Trigonometry. So let's talk about what tri means. And so in Greek, okay, so this is all Greek to you. So it's literally, right? Trigon, okay, means triangle. So polygon, right? That means like multiple sides. This is tri means three, so three sides means a triangle. Octagon, hectagon, so those are the number of sides. And metron, okay, means measure. Okay. So if I were to put these together, right? If I were to put this together, it's the study of sides and angle of triangles. Okay. So trigonometry is the study of sides and angles of triangles, of measurements of triangles. Okay. So common Greek letters used in trigonometry. Now, if you ask me why they pick Greek letters, I'm not sure. Okay, I'm not sure why they picked it. But if I would have to guess, maybe it was created in Greece thousands and thousands of years ago. Okay, so here we go. Alpha. Okay, so we've seen this before. It's like a fish. So I write it like this. So this is spelled alpha. This looks like a B, cursive B, so it's called or spelled beta. And if you can speak, you know, Greek, or you're from Greece and you think I'm totally saying these things wrong, please correct me because I have no idea. This is gamma. Okay. This right here is commonly used, is theta. This right here is phi. This right here is omega. And this right here, it's pi, which we already knew, right? 3.14. Okay. So we are going to define some vocabulary here. First, array. Array is half line that starts at a point and extends indefinitely in one direction. So array, it's half line, so half of a line. So half line that starts at a point and extends can you see that? E-X-T-E-N-D-S, okay, indefinitely. That means forever in one direction. Okay, so that's what array is. So array is a half line, so half of a line that starts at a point. So here's a point, and it can go right or it can go left. It doesn't really matter. Indefinitely in one direction. Well, we kind of use line in that definition, so let's kind of talk about what a line is. A line passes through at least 2 points. Okay, and a line doesn't have any thickness, so it can be as thick as it wants, or it can be as thin as it wants. If the line passes through 2 points, we're good. Vertex. Vertex is the angle formed by two rays. Vertex is the angle formed by two rays. Okay, so let's talk about what it is. So here's ray number 1. I have a dot. I'm going to go this direction. That's a ray. And I'm going to go another ray going this way from the same exact point. So this right here is my vertex. Okay, this right here is my vertex. Terminal side. Okay, so let's talk about the initial and the terminal side, and then we'll go back and label that in this particular drawing. The initial side is the starting ray of an angle. So remember how I started here? Okay, so initial side is the starting ray of an angle. Okay. The terminal side is the word terminal means the end, right? So it's the last ray or the end ray of an angle. So terminal side is the last ray of an angle. Okay. So, and standard position. Okay, so let's talk about the standard position. The standard position, it's when it's drawn at when the initial side is on the x-axis. Okay, so standard position, it's when the vertex, it's at the origin, and the initial side, it's on the positive x-axis. Okay, so what I have drawn over here is the standard position. So we're gonna have the initial side on the x-axis. Okay, the vertex is at the origin. So this right here is called the initial side. Okay, this is drawn second, so this is now the terminal side. Okay. And let's say that I want positive angle, which we're going to draw this piece right here, is when I draw it clockwise. Okay, so let's draw it first and then we'll write the definition. So here's my standard position. The vertex is at the origin. My initial side, it's on the positive x-axis. Let's say that I want to go positive direction, so that's my terminal side. Positive direction means I'm going to go that direction. So that means it's counterclockwise. And it's one long word. Okay. So it's counterclockwise, and then because we're going to rotate this as many revolutions we want, so we're going to put it in counterclockwise rotation. Then the next one is going to be the negative angle. So again, I'm going to draw it at the standard position. That means I'm going to have my vertex at the origin, the initial side on the x-axis, positive x-axis. And if I were to do negative angle, I'm going to go this rotation. What direction is that? It's definitely clockwise. So negative angle is clockwise rotation. Okay, and I want to talk to you about this arrow right here. This is such an important arrow when you're drawing it, because if you don't have this, then check this out. I don't know whether you're going positive angle or drawing a negative angle. So you always have to have directional arrows. So I know as a teacher, hey, is this a negative angle or is it a positive angle? Okay, so make sure you have those drawn in. Then the next couple of things are not in your book, but it's so important that we have to know it. Okay, so the next one is called coterminal angle. Coterminal angle, it's when you have two angles in standard position that have a common terminal side. Okay, so let's talk about what that is. So let's in standard position again. So here's my vertex. initial sides on the x-axis as always. Okay. When you have, so let's draw this terminal side. So the first one I'm going to draw is this. Okay, that's my, let's call this alpha. This angle right here is called alpha. Co-terminal angle, or the co-terminal angles, is when you have two of them or more than two, so that share the same terminal side. So that angle from B can be positive, and I can have another angle from here to here. Or actually, let's go a couple of revolutions, right? There you go. So that can be another one. Notice how they share the same terminal side. These two angles are called co-terminal angles, okay? So we have two angles, two or more really, two or more angles in standard position. That have a common terminal side. Okay. So let's call the red one beta. So beta is a negative angle, alpha is a positive angle, but these are called co-terminal angles because they share one terminal side. A reference angle is going to be, it's an angle that's less than or equal to. So reference angle is an angle that is less than or equal to 90 degrees that corresponds to an angle of greater than 90. That corresponds to an angle of greater than 90 degrees. Okay, so what the heck am I talking about? So I'm gonna draw a standard angle really quickly. So here we go. Here's my initial. Let's say I want to go opposite. I'm gonna go positive direction. So this one. Okay. I'm gonna end right here. So okay. Notice how I've gone one full revolution. Okay, so one full revolution. That's 360 degrees. I've gone a full straight line. That's another 180. So if I add that, and there's like this little piece, let's call this little piece 20 degrees, okay? So that little piece is 20 degrees. So if I, let's call this whole positive angle right here, it's called alpha. So currently, alpha is 360 degrees, okay, which is a full revolution, plus a straight angle, which is 180, plus this 20 degrees here. So if I add that up, that's going to be 560 degrees. Okay, so that's the black angle that I have drawn here. So 560, which is definitely greater than 90 degrees. But reference angle is the angle that is less than or equal to 90. That corresponds to an angle of greater than that. So a reference angle is really just this piece right here. You're gonna have to form this angle. Okay, so here's your reference angle. This angle is going to always form on the x-axis. It doesn't have to be positive. It just have to be formed on the x-axis and the terminal side. Because this right here is 20 degrees, so the reference angle is just simply 20 degrees. Okay, so reference angle is 20 degrees. Okay. And we're going to do some practice on that. It's really important to know what the reference angle is because we would only use 90 degrees or less to find our trig values later down the road. Okay. Revolution. You know what? I should have moved that definition above. Revolution is, so let's talk about one revolution. One revolution is 360 degrees. So that's like a full circle. Okay. So here is a full circle. Okay, that's a full circle, and that's 360 degrees. And we can also talk about radians. And down here, radians is the measure based on the radius of the circle. So is the measurement based on the radius of the circle. Okay, so let's talk about what a radius is, okay? So let's say, so right now do me a favor and put your pencil or pen down and just listen to me. It's going to be confusing if you try to write and listen at the same time. So here is a circle. Okay. Here is a circle. I would like to find the circumference. Okay. The formula of the circumference is 2 pi r, right? The formula for circumference is 2 pi r. What if my radius is 1 unit? The radius is 1 unit, so that means 2 pi times 1 unit equals 2 pi, right? So a full circle, which is a measurement of 360 degrees. 2 pi, it's in radians. Okay, so 2 pi equals 360 degrees, and that's degree, and 2 pi is in radians. And the reason it's called radians because 2 pi represents the arc length of the whole circle. Okay, and arc length is like, think about the pizza and you're eating the crust of the pizza. So the reason 1 revolution equals 2 pi radians is because it's just simply, okay, can you find the arc length of a circle? Which is, the arc length is the outer piece of the circle, and the outer piece is the circumference. But if the radius is 1 unit, then the arc length, it's 2 pi radians for the entire circle. That is why I'm going to write this again. 2 pi radians equals 360 degrees. And this is so important that you should memorize that piece, okay? So in this box right here, we have, I spell it out for you. 1 revolution equals 360 degrees equals 2 pi radians. That means if I divide 2 on both sides, if I take this and divide by 2, which now gives me a pi radians, if I take this divide by 2, that gives me 180 degrees, okay? Now, if I were to divide this equation, divide each side by 180 degrees, then would you agree that 1 degree equals 2 pi over 180 radians? And if I were to take this equation and divide both sides by pi, then 1 radian equals 180 over pi. So these two bottom equations, it's just simply dividing this piece right here by opposite, so 180 or pi. Okay, so we're gonna turn to the next page to see what we have left. And it looks like I kind of staple example E here, so let me just undo the staples. Okay. All right, example E. I'm sorry, example E. Example 1. Example 1, convert each angle in degrees to radians. So if it's in degrees right now, you're going to convert it to radians. Express your answer as a multiple of pi. That means I don't want you to use a calculator. Okay. So 30 degrees, we're going to take, remember, so let's talk to reminder here. What reminder? Okay. 360 degrees equals 2 pi radians. And by the way, if we don't have the bubble next to a number, it's gonna, by default, is gonna represent radians. So if you don't want to be radians, you have to put the bubble on it. Okay, that means 180 degrees equals pi radians. Okay, so we're gonna use this right here. So we're gonna have 30 degrees, and I would like to convert it. Okay, I would like to convert it to radians. So that means I'm going to multiply. I can make my 30 into a fraction. And if I'm going to radians, right, 1 pi radiant, radians equal to 180 degrees, so I can put 180 degrees on the bottom, so that way my degree symbols will cancel out, and a pi radiant on the top. Okay, so this means if I were to cancel, the bubble and the bubble cancel each other out, or the degrees and degrees will cancel. 30 going to 180 6 times, right? So you can reduce, divide that by 30, you get 1, divide by this by 30, you get 6. So my answer is pi over 6, and it says leave the answer as a multiple of pi, so since I can't use a calculator, I'm going to leave that as is. And I don't have to write the word radians, so by default, if there's no bubble written next to it, then it's just going to be assumed it's always a radiant, okay? Alright, next we are going to do 120. So 120 degrees, and I would like to convert this to radians. So I'm going to go and multiply. I'm going to make this into a fraction because I am going to get rid of the degrees. The degrees is going to be in the bottom, so 180 degree is a pi radians. From here, I can definitely cancel out the zeros and the degree. So if I don't know what I can reduce it to, I'm going to do a couple of steps here. 12 pi over 18. They're both even, so I'm going to divide each and everything by 6. Okay, divided by 6. Then 12 divided by 6 is going to give me 2 pi. And 18 divided by 6 is going to give me 3. Or you can even write, so 2 pi over 3 radians, or you can write 2 over 3 pi radians. Okay. So your pi can be on the numerator, or your pi can be on the side, but never the denominator. Alright, so what I would love for you to do is complete these 3 right here on your own. Okay, go ahead and convert C, D, and E into radians. And if there's a negative degree here, that means your answer is going to be negative as well. Okay, negative is just directional. Am I going to go clockwise or counterclockwise? Negative is always clockwise. Okay, positive is always counterclockwise. So, on your own, I would like to complete this. And that is the end of the notes. Please hit complete those one before you wrap up for the day.